Hello, and welcome to this edition of the CSIX podcast series. This is a multi-part series entitled Fifth Generation Cellular, conducted by CSIX MEs Dr. Carl Kucha and Dr. Paul Losowitz. This series will explore a broad range of aspects regarding 5G wireless networks. This episode will discuss 5G infrastructure changes and examine the varying properties of different frequencies. Multiple private network architectures, as well as INL secure wireless capabilities, will be described.
So let's go on to the next chart and talk a little bit about the differences of the frequencies and what some of the physical properties of those are. And then we'll get into some of the international things that are going on in these spectrums and things like cybersecurity and some of the ways these systems are being rolled out.
Okay.
So the first thing I'd like to talk about is the difference between the lower frequency ranges, which are anything from the 600 megahertz up into about 1.8 gigahertz. Then there's a mid-range, which is about 1.8 to 6 gigahertz. And then we've got the very, very high frequency, which is going to be those frequencies that are the 23 up to 50 gigahertz. So there's two trade-offs here we have to talk about. And on this chart, we kind of show all three things. So that circle that you see going way out to the right, and it says extended coverage with dynamic spectrum sharing, DSS, or frequency division multiplexing, or FDD low bands. So low bands are low frequency. Gives us a lot of range. I mean, we not only have range, but we can go through buildings, penetrate walls, things like that. It's a fantastic system for rural areas. It's a fantastic system for high density areas because it gets through buildings and stuff like that. The trade-off is we don't have very good latency, which is the time it takes to get a command through, and we don't have very much bandwidth, which is what controls the speed. So we can get great connectivity, not really great control or bandwidth. Come back a little bit, and we get what's called the time division multiplexing, TDD, and that starts using what we call the mid-range. And that area in the mid-range gives us a lot of capability. It's a great spectrum for doing things like, high density city work, high density factory work. It still has decent penetration. So remember, these are the 2 gigahertz to 6 gigahertz ranges. It has a good bandwidth and it has very good latency. All right. Now, one of the disadvantages is when we get into some of these high density applications where we're talking 1 million devices per square kilometer, it still doesn't have enough resolution speed to drop that many devices into the same area. So now comes the highest of the high band of the 5G, which has the least range, but man, it has got killer throughput and it has got fantastic latency. The good thing about that is that I can create these small cell zones with very, very small distances, and I can pack them in next to each other. So I can get high density. That's where we get 1 million devices per square kilometer. So when I talk about small areas, I'm talking about a single house, maybe a single apartment, a single, warehouse where you don't have walls and stuff like that. Those kinds of things have got super high capability for a lot of devices and really great control. If we get into the area where I want to go rural, these kind of devices are really hard because I've got to put a boatload of them in when I don't have the revenue stream or the usage to really justify that many devices. So there's a little bit of 5G for just about anybody here, and there's trade-offs in where you're going to go. So let me show you just a really quick example of what one application might look like here.
Okay.
So here's one application where you've got one millimeter wave transmitter that's in a home. So inside this home, everything that is in that home will be connected to a 5G. It's very similar to what Wi-Fi is, but the
Right.
advantage of this is that you have all of the advantages of having Verizon or T-Mobile Sprint or AT&T connectivity nationally. And then this gives you all the control, all the bandwidth, and fantastic latency all the way through the system. And remember, when I say latency or the speed it takes to get something to execute, I don't mean just the link from your device to the wireless transmitter. I'm talking end to end. So this is going to be an entire network revolution. So we can bring this right into your house, right into your office, right into your warehouse. But I'm going to have one of these millimeter wave transmitters on every house, every major warehouse segment, multiple ones in big apartment buildings, stuff like that. So that's kind of the trade-off in the use case.
Okay. Well, let's go on, Carl.
Great. All right. So the next thing I'd like to talk about is how some of these things are getting executed. Because you might have noticed that if I've got a transmitter in my house, I bought that transmitter. So who controls what that transmitter does? And we also would have the same kind of issue if we put a transmitter into a major warehouse. Did the people that own the warehouse, do they control the transmitter? And how much of the network do they actually control? In the 4G example, that everything that the network did, all of its controls, all of its cybersecurity, everything on how it was provisioned was all controlled by the major carrier. So Verizon, for instance, you could have bought a 4G small, what's called a femtocell to put in your house, and Verizon had absolute control of that thing when you plugged it in.
Right.
Now, 5G is the first cellular system where we're actually going to allow different types of scenarios for different situations to exist in the 5G ecosystem. So if you look in the left-hand side, you have what's called an integrated private network. Now, this is where the vendor has sold a piece of equipment to a company, and if you look on the bottom there, where it says private network, right? The entire network, if you disconnected it from AT&T or Verizon, the entire network still operates within my facility. I could still call other people. My machines are still running. It's still connected to my main computer controllers. Everything still runs. And I leave by going through that firewall and then going back up to Verizon. Now, there's that dotted line across the middle there that control node talks through the firewall that talks to my private network. And I should have said here that the integrated network on the left still allows for Verizon to control.
Okay.
But the point being, once it's set up, if it's sliced, it still operates. All right. Over on the right-hand side, where the independent private network, we have even more remoted control. So in this, you can see in that private network box, the control node is existing as part of the private network, which means that the private network guys are in full control of that network, which means that they control the security, the gateways, who gets in, who gets out, everything. And none of that control actually exists, or very little of it exists, with the main carriers. So the carrier itself still can talk down and receive the signals and get those phone calls and data links through for the company, but that company would control everything else. Now, this is great for companies that know what they're doing and they need enhanced security, like the military. But there's going to be a lot of companies, we fear, that are going to install these kinds of systems and are not going to have the expertise to install appropriate cybersecurity controls. Right. So this is a potential cybersecurity threat. The other thing is we've had conversations with Qualcomm, for instance, and Qualcomm has most of the chips that go into 5G systems, and Qualcomm has relayed that we have installed, this is Qualcomm speaking, we have installed every security feature in the standards in our chips. It's all there, but it's all software controlled. So
Right.
if a vendor creates a device that is using our chip, they can have some of those security features switched off. And it's important that whoever is using these devices understand how that security is implemented and how that's going to be evaluated and tested. If it's a Verizon, I'm pretty sure they're going to do it right. If
Okay.
it's mom and pop's smart meter shop that just started up last week running on a shoestring budget, and we got to check those guys out. So test and evaluation is going to be critically important for these systems going into the future.
Okay. And I understand that local or regional implementation of the standards can vary. So if I'm trying to presume interoperability internationally, I'm going to have to be prepared to identify those variances and operate within them, correct?
Exactly. That's exactly right.
Okay.
Especially, and we'll talk about zero trust networking a little bit, but that's the whole core of it, is that there's so many things that could be set or unset on these 5G systems that we basically have to go, if we're going to use them, we have to go in with our most trusted information, assuming that it potentially could get picked off during the transmission from our user device out to the endpoint. So we can't really trust the network with anything super critical. I'm talking like
Okay.
classified information here.
Right. Okay. Well, let's go on, Carl.
All right, thanks, Paul. All right, so let's go to a couple of topics on INL capabilities and what INL, why does INL have any credibility in this space? So I'll give you a little bit of review about who we are.
Okay.
So Idaho National Lab was an 890 square mile facility with 7 major industrial complexes. But other than that, it's a very remote area, and it happens to lie in a depression which was a gargantuan volcanic caldera from about 3 million years ago. But it works to our advantage because it's a natural outdoor anechoic chamber, very quiet area. But we also have the ability to test communications links in a variety of situations, from mountainous to very dense industrial areas. Because of this, INL set up about 20 years ago the wireless test bed, and since that time we've been doing cybersecurity research and full-scale testing on communication systems that do include cellular ranges as well. But we do satellite, HF, land mobile radio, and the interplay between all of these, as well as how all of these things tie into the power, the cyber side, the control systems, and the wireless communication side. So to do all of that, we've got a three-pronged approach. Basically, we have a wireless group that does development of new waveforms and new solutions.
Hmm.
In the area they're working in primarily right now is in dynamic spectrum sharing. How do two guys that are supposedly got licenses to the same spectrum work together without causing each other interference? We
Right.
have electronic warfare. Oh, sorry, Paul, go ahead.
Yeah, which is essential if we are in fact trying to share pre-allocated spectrum for 5G that, let's say, the military has already put into use for some other other service. Okay.
Right. We have a electronic warfare modeling and simulation group. We're active with the U.S. military and maintaining programs that they use that can simulate what would happen if there is electronic warfare in the area. And then finally, our full-scale test and evaluation unit has been working tirelessly for 20 years. They've had thousands of people, tens of thousands of test hours out on the range. So it's a very, very mature, great group to work with, and very technically oriented.
Okay.
So here's the 7 facilities that we have out on the range, and what's important here is that each one of these facilities represents a different infrastructure that is going to be one of the new infrastructures that's going to be uniquely enabled by 5G. So the electric power grid, nuclear materials R&D, we do a lot of radiological work, but large-scale manufacturing, testing to scale, large-scale testing that we do. We don't blow things up just for the purpose of blowing them up, but usually for protection. We have a large research group, and then finally on the left, our crown jewel, which is the wireless test bed with all of our cellular work. And this range has not been set up exclusively as a research range. It's been set up as a full-scale Tier 1 wireless network that can be configured to represent any wireless network around the world.
Outstanding.
So all the different frequencies, all the different communications media from the United States all the way through Europe, the Middle East, and Asia have all been represented out on this wireless test bed. Again, I said a little bit about the folks that work here. We've got 40 full-time guys that work just the wireless test bed. We've got another 30 research engineers that work back in the labs. So it's about 70 folks total. And they basically come out of industry. So these are guys that know how things are done and how things would be reacted to if there were perturbations to the system. So it's a very prized group. We get a lot of DoD folks that come out to the range and want to do testing, particularly exercises to prove that a tactics, techniques, procedures, and equipment would work in the field as expected.
Outstanding. Okay.
We also do wireless security work. So we've stood up what we call the Wireless Security Institute. And what we're trying to work on is resilient, not just secure, but resilient communications and all of the testing around that. There's a research component to that, as well as a testing and evaluation component. And we've already started partnering with some of the larger units like Samsung, Qualcomm, and Verizon's going to come out, potentially partner with us. And we're talking with T-Mobile. I mean, those are the kind of folks that work with us on these things.
On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content informative and useful. If you would like to provide feedback or comments, please visit our website at www.csiac.org, where you can also find additional content to review. Thank you.
Did you know that CSIAC offers free monthly webinars featuring experts in the areas of cybersecurity, software engineering, modeling and simulation, and knowledge management? Come see leading industry professionals talk about industry practices and leading research. Make sure to visit www.csiac.org/webinars in order to subscribe to our mailing list and see when the next webinar series is available. There you can also watch previous webinar series to catch up. Visit www.csiac.org/webinars.